Welcome to the next lecture of design and analysis of algorithms. In today's lesson, we will discuss and we will analyze heap sort algorithm. So let's see what we'll talk about in today's lesson. We'll talk about the concept of heap sort. We'll see an example how heap sort is done. Then we'll talk about space complexity and we'll talk about the time complexity. So let's first discuss what is the simple algorithm for the heap sort. So the heap sort, the first step of the heap sort is to build max heaps. I'll show you right now. Then we'll iterate because we're building the max heap. Then we'll need to iterate and we need to exchange the root element. We need to exchange the root element with the last element of the heap. Once we perform this exchange, we'll extract the last element from the heap. And that means we are reducing the heap size by 1. So we'll reduce the heap size. This has to be -1. So we'll reduce the heap size by 1 as we have already extracted the last element. And then again, we need to perform max heapify. So now let me talk about what is this build max heap, what is this exchange, and how we can do this reduction and how we can perform max heapify. Let me rewrite this algorithm into very simple steps. So let me write it into a simple steps. So this step number 1, that's the build max heap. In that, I'll divide this step into two parts. The part number 1, build heap. So I'll simply build a heap, and in step number 2, max heapify. I'll show you with an example that what we mean by this max heapify. So basically the heapify is a property, max heapify is the property that we need to keep into that heap. So the step number 2 is max heapify. Once that heap is max heapified, that means we have preserved the heapify property into the max heap. Then we need to perform this exchange. So we will do the exchange. So we will do the exchange, and what we'll exchange the root element with the last element. So exchange will be performed, and then next step, step number 4, reduce heap size. So we'll reduce the heap size by 1. This is the next step, and then step number 4, after 4, the step number 5, then we'll again perform max heapify. Then we'll again perform max heapify, and then the step number 6 is repeat till only one element left in the heap. As we are reducing the heap, so we need to repeat this process to be left with one element in the heap. Then we'll have a sorted list. So this is a simple version of the algorithm. It's easier for me to understand. So let me show you all this with one example. Now let's understand the heap sort with this example where we have an array of elements and we want to sort them with the help of heap sort. So we'll apply the first step, that is build a heap. So how we can build the heap? We'll start with the first element. This is 5. This will be at the root. Then we'll fill up its left child, that is with the next element, that is 3. Then we'll fill up with the next child, that is the element with 17. So we'll complete level by level as we are building a heap. Now the next is we'll again start from the left hand side. So we'll take the left child of this 3 and we'll fill up the element 10. So now the right hand side of the 3 and we'll fill up this with 84. Then we'll come with the 17, the left child of 17, and this will be 19. So the next child, right child of the 17, this will be 6. Then again, this level is complete. We need to move down to the next level, and again we'll start from left to right. So this will be after 6, we have 22, and then as a right child of 10, we have 9. So this is the step number 1, that is building the heap. So this is 1, 2, 3, 4, 5, 6, 7, 8 and 9. So this is the step number 1, build heap. Now the step number 2, max heapify, and combinedly these two steps are known as build max heap. So we are building max heap. So now just to build max heap, what is a max heap? Max heap is a heap where the largest element is on top and all the elements are smaller than this parent. So in any subtree, the parent is the largest element and the child or the children has to be smaller or equal to the parent. That's a max heap. So that means the largest element should be on upside and the smaller element should be on the lower end side. So we'll check whether this is a max heap or not. So we can see that this is not a max heap because we can say that even in this subtree, the parent 5 is smaller than 17. This is the violation. And even you can see that here in this subtree, the 3 is the parent. This is smaller than the 84. So these are the violation of the max heap. So we'll convert this into the max heap. How we can convert this? We'll start solving with subtrees. So we'll start doing this with the bottommost level from the right to the left subtree. So we'll start with the bottommost level from the right to the left subtree. So let's say, what is the bottommost level? This is the bottommost level. The right hand side element is 9. We do not have any child of this, so the property does not apply to this. We'll come to the left hand side. This is 22. So this is again leaf node. The property will not apply to this. Now we'll jump to next level. So let's see, this is 6, single leaf. The property will not apply. 19 is single leaf. 84 is also a leaf. So now our actual node is 10. So we will see this subtree and we'll check whether in this subtree the max property applied or not. So we can see that here 22 is lower down, it should be up. As we know, what is the property? That the parent should be larger than its children. So it's violating the property. So what we need to do is we need to perform a swap. So how we'll do this? We'll swap these 10 and 22 with each other. So this 10 will come this side and 22 will go this side. So this is the swap that we do into this. So this is 10 and 22. So we have seen this tree. Now we'll move up. We'll move the upper level. So now we'll see this subtree. And we need to check whether it's according to the max property. No, it's not according to the max property. This is violating 70 and 19. So what we need to do is we need to swap these. So the 17 will come down. We'll perform a swap. And 19 will come upside. Right, so this is the second tree. Now we will need to see the third subtree from the right to the left. So this was the right subtree and now we'll see this left subtree. So in this left subtree, we'll see whether the property is violated. Yes, the property is violated. We can see 3 is upside, 22 is larger and even 84 is larger. So now we see that 22 and 84 both are larger than 3. So which will be swapped? Obviously the larger one. So 22 and 84, we have a larger one, 84. We'll swap 84 with 3. So we'll do a swap in between 84 and 3. So this will be swapped. 84 will go up and 3 will come down. So it's the 3. So we have done with this level. Now we need to move to the top level. So this is the subtree in the top level. Again, the property is violated. We need to swap. 84 and 19 both are larger than 5. So we need to see which is larger in between 84 and 19. 84 is larger. So we'll swap this 84 with 5. So 84 and 5 are swapped with each other. So we'll have a 5 here and we'll have an 84 here. So by doing this, we'll see whether now our heap is a max heap or not, whether the heapify property is now into this tree. No, still we need to make some more changes because still the property is violated. So we'll start from where we have done. We'll begin again in the same way from the bottommost layer and we'll move to the uppermost layer performing these swaps. So let's start again. Okay, so we'll start again. We'll take the bottommost layer, and we know these are the leaf nodes, so we'll not touch these leaf nodes. So this is our first subtree. We need to see this is according to the property, the parent is larger than both its child, so we'll leave it as it is. Then we'll talk about this subtree in the upper row, right to left. So this is again following the property, and into this is again a violation. So what we need to do is we need to swap this 22 with 5. So we'll swap 22 and 5. So this will be 5 here, and this will be 22 here, right? And we'll go up and we see that this is according to the property. So we have done one more swap. Again we'll do the same from the bottommost, and we'll see now again this subtree is violating the property, so we need to swap the elements. The larger element is 10, so 10 will be swapped with 5. So 10 will come up and 5 will come here. Now we can see after doing all these operations, now this is heapified heap, right? So this is max heap. We have built max heap here following these first two steps. Now 84 is the largest, 22 and 19, and 22 is larger than 10 and 3, 19 is larger than 17 and 6, and this 10 is larger than 5 and 9. So this is your max heap. So we have built max heap. So once we have done build max heap, our first and second steps are completed. Now what we need to do is we need to exchange. We need to perform exchange. If you remember what we need to exchange, so I need to perform the exchange. What will be exchanged? The root element will be exchanged with the last element of this heap. What is the last element? This 9 is the last element, which is the root. This 84 is the root. So we'll swap these two with each other. So 84 will come here and 9 will come on top. So this is the third step, that is the exchange step. So once we have done this exchange step, this 84 will be removed from the heap because now it's on its place. So let me create this array, and we'll put this 84 on its last position. So 84 will be removed. So we have reduced the heap size. You can see that we have reduced the heap size by 1. So this is the reduction step. So we have reduced the heap size by 1. Now again we need to perform max heapify. That means we'll have to check whether this is a max heap. If it is not, then we'll have to perform all the steps. So again we'll start from the bottom to the top, from the right to the left, checking all the subtrees for the violation of the heapify, max heapify property. So you can see this is a leaf node. We leave this. Again leaf, leaf, leaf. We'll leave all these. This is the subtree. It's not violating any property. We'll move up from the right to the left. This is a subtree. It's not violating any property. Then we'll move to the left side. You can see this is the subtree. It's again not violating any property, but yes, this top one subtree is violating the property. So we need to swap this 9 lower. We'll swap, we can see 22 and 19, which is larger, 22. So we'll swap 9 with 22. So 9 will come here and 22 will come here. Now again we'll go on the bottommost, and again we'll check all the properties. 10, 5 and 10, yes, it's right. This subtree is also right. This subtree now is violating the property. So we need to swap 9 here and we need to swap 10 here. Right. So now again we'll check from the bottom to the top. Right, now this subtree is on its place. There is no property violation. This is no property violation. This is no property violation, and this is no property violation. So now this is a max heap. So this is a max heap. We have performed max heapify. Now we need to repeat till we are left with one element in the heap. We are having lots of elements, so we'll repeat this step. What is step? We'll go back and we'll exchange. Again we'll exchange what two elements will be exchanged together. This 22 and 5, the root element with the last element. So 22 will come here and 5 will go up. Right, so once we have done the exchange, we'll reduce the size of this heap by removing the last the largest element from this heap. So we'll remove this 22 from this, and the 22 will be kept in the array in the second last position. So now we can see we are left with a reduced heap. Then again we'll need to perform max heapify. So now again we'll start from the bottommost, leaf, 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 we'll leave it, we'll go up. So this is the subtree, so there is no property violation. Now this is another subtree, 10, 9 and 3, no property violation. We'll move up, we can see 5, 10 and 19, so there is a property violation. We need to swap from 10 or 19. 19 is larger, so we'll swap this 5 with 19. So 5 will come here and 19 will go up. Again we'll go to the bottommost, we'll do the check again. So this is the right subtree first, there is a property violation, so we need to swap. What we need to swap? 17 and 6, which is larger? 17, so we'll swap 17 and 5 together. So 17 will come up and 5 will go down. Again we'll check, this is there is no property violation and there is no property violation. Now again this is your max heap. So once we have got the max heap, again we need to perform exchange. So what we'll exchange? This time we'll exchange the root with the last element. So the root is 19, so we'll pick 19, will come here and 6 will go up. So this is the exchange. And once we have done the exchange, what we need to do is we need to reduce the heap. That means we need to extract this 19 from this heap. So we'll extract this 19 from this heap because 19 will come this side. So the 19 is out of the heap. Now again we need to perform max heapify. So this process will continue. Let me do it once again, the max heapify. So let's see from the right hand side. This is now 17 and 5. This is now 17 and 5. It's not violating property. 10, 9 and 3, it's not violating the property, but yes, on the top this 6, 10 and 17, this is violating the property. So we need to swap the larger element, 10 and 17, 17. So we'll swap, 6 will come here and 17 will go up. Now again we'll check the properties. We can see it's not violating, it's not violating, it's not violating. So now this is a max heap. So once we have got the max heap, again if you remember, what we need to do is we need to exchange. We need to exchange this root element with the last element, and which is the last element? That is 5. So this 17 will be exchanged with 5. 17 will come here and 5 will go up. So once we have done the exchange, we need to extract the last element. So we'll extract this 17 from the heap. We'll extract this 17. So the 17 will come here. And now we need to perform heapify again. So we'll perform heapify again. So we'll see, okay, leaf, leaf, leaf. So this is the first subtree, 10, 9 and 3. No property violation. So we'll go up 5, 10 and 6. Yes, property violation. So we'll swap this 10 with 5. So 5 will come here, 10 will come here. Now we'll again go to the bottom and again check for the violations. So we can see there is a violation. So 9 will go up and 5 will come down. This is a max heap and we need to exchange the elements. So which elements will be exchanged? The root and the last element. 10 and 3 will be exchanged. So here it will be 10 and on the top it will be 3. Once we have done the exchange, we need to perform reduction of the heap. So that means we'll extract this 10 from the heap and we'll reduce the heap size. So this 10 will come here and the heap size is reduced. Again, we need to perform max heapify. So let's see, this is the first subtree, no property violation, and this is the next subtree, the property violation. So this 9 will be swapped, 3 will come here, 9 will come here. We'll go down, again we'll see the property violation, 3 will come here and 5 will come up. So now this is again a max heap. What we need to do is we need to exchange the root element with the last element. So here it will come 9 and here it will come 3. And once we have done the exchange, again we need to reduce the heap. So we'll eliminate this 9 from the heap and 9 will come here. So So now we are left with a very small heap and we need to perform heapify onto this. Again, we can see that the heapify property is violated. So from 5 and 6, which is larger, 6 is larger, we'll swap 6 and 3. 6 will come up. So now it's a max. Again, we need to swap. So how we'll swap? We'll swap the root with the last element. So this will come here and this will come here. So after the exchange, we need to perform extract. So we'll extract this 6 from the heap. 6 will come this side. Now we are left with a very small heap and we can see that it's not following or fulfilling the max property. We need to perform heapify. So on heapify, now this is your new max heap. Then again, once we have done the heapify, we need to swap these two elements. So the root will come here and 3 will come here. So this is a swap basically. After the swap, what we need to extract. So we'll extract this 5 and we'll reduce the heap. So this 5 will come here. And now we can see that we are left with only one element into the this heap. So we are come to an end because in the last step it said repeat till only one element left in the heap. So we are left with 3. Automatically 3 will come here and we can see that we have a sorted array. So this is how we perform the heap sort. Now let's talk about the space complexity of this heap sort. So we can see that this build max heap will take the space of n, s of n, and next is the loop. And then we can see within inside the loop, this exchange statement will take the space complexity of 1 because it's just the exchanging or swapping the two values. Then we have the heap size. So we need to reduce the heap size. That will also take the space complexity of s of 1. This is just the exchanging. And next is the heap max heapify. So max heapify, again it will take the space of unit n. So the space complexity of this heap sort comes to be of order of n. So we can say that the space complexity is of order of n for the heap sort. Now let's talk about the time complexity. Let's discuss what will be the time complexity. As now we know that the time complexity for this build max heap is of order of n. So this is build max heap that takes the order of n, and then this is exchange will take the order of 1. And now again this heap size reduction will take the order of 1. And lastly this max heapify that takes the time complexity of log n. So right, this is time complexity of log n, and as we can see, every time we are doing this loop, we are building the heap, we are building the max heap, and then we are performing max heapify. So we need to perform the product of these two time complexities to achieve the final time complexity. So the final time complexity is of order of n log n. So the time complexity for the heap sort comes to be order of n log n. So I hope you might have understood the concept of the heap sort. Thanks a lot for watching the video. We'll meet in the next video with some more sorting algorithm and their analysis. Thank you so much.